Okay, we continue on with lesson 4.3. We start with part 1. This actually is um, your discussion assignment. So we want to make sure I'll do the next problems at part 2, part 3, and part 4 so you know how to do these. So let's go ahead and take a look at part 2. Here again, where we're going to now apply quadratic formula and Desmos to solve these equations. So important, we're going to use quadratic formula and Desmos to help us answer these questions, because these numbers are going to be decimal numbers and they represent something from the real world. And so here's a situation where we're looking at where t is the number of years since 2000. So again, it doesn't have to be x and y. We can use different variables. R is the rate of admissions per 1 million people. And so R in terms of the number of people who've been treated for opioid addiction. So you can see, use Desmos to determine the year in which the rate of admissions reached 100 people. And so 100 people per million. So every 100 people out of a million, right? When does it reach that? So we can look at this graph here, and you see this equation here. This is what it would look like on Desmos. And so one way to solve this would be through quadratic formula. I want to know when this equation equals 0, 100, right? Because this tells us the rate at which people are becoming addicted to opioids. And so notice you set this equal to 100, and then to use quadratic formula, right? You then set that equal to 0 by moving 100 over, and you get this, and then this is your A, your B, and your C. And when you substitute in there, you can then see you get these values. That's what you should get from the quadratic formula. And so then these numbers is the time when it equals 100, which is this value right there, right? This is where it equals 100. And so the only one that we're interested in really is we're only interested on this half of the curve in this case. The other side is not part of our problem because we're only looking years since 2000. So technically we don't need to use the left side. So we only have this one answer, which it occurs at t equals 15.7 there. You would get it through the quadratic formula, A, B, and C, or by, again, once you have that in there, you can use Desmos to determine that, which I'll show you in another problem too, how to do that. And then how many answers did you get? Of course, 2 answers, but we're only using 1. So we left off here. So here we go, leaving off right here with the 2 solutions, but only one being used. Let's go ahead and look at another problem. Here's the airline charter profits problem, part 3. Again, you have a quadratic equation. And so how would we use Desmos to solve it? Let's go ahead and set that up. The equation on Desmos here. I'm entered in the equation that's from the worksheet. The hard part many times because of the numbers is trying to get the window set up. So my first thing is just to use this here so you can start to see the graph. The problem is you can see how it runs out of space. So what I end up looking at is I see, okay, the x-axis -20 to 100 and the y-axis 0 to 20,000. So that's where you would, this is where you would go to the wrench x-axis here, -20 to 100, and then you can see the graph comes in. And if I needed to change the y, I would have went like from 0 to 20,000, but it fit in for us there. So now I can see the graph, and then I can see again, I'm answering when does, based on it, what is it, when the profits are 0. So that occurs right here where it's 0. And so I can't read those, they're estimates, unless I get to Desmos, and then I can click here, and then you can see that 2.35, 2.3, and 85.6 or 7. So we have that answer there. And so that's where I get those answers. I think it should be 85.7, huh? I think I rounded wrong if I do it again. 85.7, if that is what I should be putting in right here, not 85.6. So that's a 7 to 1 decimal place, and those are those numbers there. Now you read the next question. The company tries to make at least $10,000 in profit. Use the quadratic equation to determine what size group would need to reach that goal. So what you're really solving is, if you look carefully, I set the quadratic equation equal to 10,000. And then you go ahead and solve. You should get around 17 and 70. Again, when you do that, you end up with an equation like this, and then there's your A, your B, and your C. There's multiple ways on Desmos to check your work. One way would be, I want to know when the P was equal to 10,000, so that's when the Y value was 10,000. And so I notice I type that in, you put that here and here, and then you can see it's 16.9 and 71.1, so around 17 and 71. Or 70. Again, those are just approximations, but you'll get the exact answer. Use quadratic formula, 17 and around 71, I would say, not 70 here. I'm off on my numbers here, so let me just record that so you can see it's and 71. These are approximations. The other way would be, after you solve this, set for 0 here, then you would use you can solve this for 0, because what would happen is, if you end up with this equation, you end up with that equation, but this time, notice that when I solved, subtracted the 10,000, it's minus 12,000 now. And so in here, the problem's a different problem. Now I'm setting that when that equals 0, but notice they're the same numbers. So multiple ways to solve that, but you get the same answers if you look carefully there. And then the last one here, similar question here. You have this equation regarding the percentage of workers who use computers on their job. There's an equation here. You want to graph that. You would look like this here using Desmos. You would type that equation in. Here's what the graph would look like. You want to at least make sure you can translate that by hand. Take those numbers from here and then be able to give you an accurate estimate of that. And then answering the questions here just to these questions here that you're looking at for B, C, D, and E are over here in the graph. Let me zoom in a little bit. And so looking at some of these answers here, there's the equation at 50. At 50, first you have the vertex, and this is kind of the, what we say, your axis of symmetry here. And so I plotted the wrong. At 50, you end up with 52, and then the symmetric again, so 52% of the people, again, based off of this question, 50-year-olds, 52% of 50-year-olds use computer at work. There's a symmetrical point on this other side, and that is related to 32. 52% of 32-year-olds, and so that's using the symmetry. That's this one here, using your symmetric point and getting the other point on the other side. The other question about when draw the line y equals 40, and then use the quadratic formula. What you would end up using is, there's your 40 line, and there's the points of interest, and what you're trying to find out is trying to find the x value. So you get an approximation here. So again, looking at trying to answer that question, you would end up solving, so going down to 40, I'm here, you would see what those points are. I get 23.1 and 58.9, and so from here, that means about 40% of 23 and 59-year-olds use a computer at work. I just rounded to get a closer number. We're talking about years age. notice again, to solve the quadratic formula, you would, if you set it equal to 0, and then you have your new A, B, and C. And then to answer this question over here, which ages, describe the ages for which more than half the workers use computers. So I'm setting that equal to 50, and you would end up solving. And again, looking at here, you could see I have the equation in, and again, I have 140 and 50, and then I can see I get those solutions using Desmos. So you can see 50 when it equals 40, those ages I got, and then 30 and 52, 30 and 52, not 50. So this is a 52 that we're looking at. 30 and 52. Oh, that's, this is a 30, not a 30. That's it, not a 32. 30 and 52 give us those answers that we have over here. That's it.